Okay, so you guys still see it?
Yep, I see it. Thanks.
Okay, and this was an interesting case to kind of highlight the importance and things we're always dealing with these winter weather events. Of course, the antecedent conditions with respect to the ground temperatures and that air mass that precedes the precipitation. Also, the role and how just even subtle aspects of timing can go from really an innocuous event to something a little more significant. So we deal with the meteorological timing aspects of it, and then also I'm going to touch on the timing with the societal aspects of it. In other words, is it coming during rush hour or holiday or something like that? And really emphasize this January 19th, 2005 event where a half inch of snow basically led to a significant disaster. And I'll talk about some of the impacts. And this was in the Raleigh area. And I believe this was still right before where we going to do advisories or warnings based on impacts. We primarily looked at specific values, and if we didn't reach those thresholds, then we didn't issue an advisory or a warning. And in this particular example, they had snow in the forecast, and the amounts were right across most of the area, but it didn't warrant an advisory or a warning. And when you see this, you can see it's obvious we needed something regardless of the amounts. And that's really driven by those antecedent conditions, with a lesser extent the amounts that had occurred. So let's take a look at this particular event, and this shows the setup, and hopefully the loop is showing really light snow coming across the area, and it was a really fringe event for us. If I recall, we did have some flurries work across the Wilmington area and mainly our northern zones, but the bulk of the accumulations, as you'll see from the plot that I show, are generally from the Raleigh area, with the bigger amounts north of Raleigh towards the Roanoke Rapids and parts of Virginia. But basically, the setup was defined by the Arctic air mass that was in place before the precip began, the societal aspects of we've got a population that's not experienced with winter weather compared to other parts of the country, and then you sprinkle in a little bit of P-type issues, and then the people hit the roads, and you've got an instant snow disaster on our hands here. So when we look at the actual accumulation graphics, you can see just generally trace amounts, and we did have some flurries in our area, but for the most part, the bulk 1 to 2 inches of snow fell in the north central part of the state, and that was about the area where they were under forecasting. I think their forecast was for less than an inch, most of the area responsibility. But basically, this resulted in 8 hours of traffic jams. Normal 40-minute commutes turned into 8-hour commutes. That's how terrible it was. The amount of accidents was just incredible in that part of the state. And Raleigh PD responded to 422 accidents just between 11 a.m. and 9 p.m. The Highway Patrol in the surrounding areas responded to 200 accidents, and the Durham Police had 150 accidents just within a 3-hour period. And the roads were so dangerous that the schools decided to bring the kids back or keep them in place. And as a result, in Wake County, 3,000 students were stranded overnight at more than 50 of the area schools there. And it was this half inch to inch amounts, resulted in the governor declaring a state of emergency in Wake County. And they actually had to open shelters for not just dealing with the kids, but also dealing with stranded motorists as a result of this. So it was just an incredible event that occurred. And what makes it even more incredible is how little it took to cause this. So these disastrous road conditions, basically a few things coming into play here. Of course, the weather aspects of it, and then the behavioral factors and the lack of experience, and that led to that mayhem that we saw on the roadways there. And just to talk about the synoptic setup here, in the image on the left-hand side was a surface map analysis, 7 a.m. the day prior to the event, and what we see is big Arctic high, 1040 plus high, centered over the Ohio Valley, sprawling across the eastern U.S. into the deep south, and then a clipper-like system there starting to move its way out of Canada towards the Dakotas and approaching the Great Lakes region. When you look at the image on the right, the morning of the event, that clipper has moved towards the Great Lakes, approaching the Ohio Valley, and that Arctic air mass is kind of getting strung out along the eastern seaboard. When we look at the 250 millibar analysis. And this isn't our typical snow case. I mean, you saw what Vicky had presented with Tim's information, the Miller A, Miller B. It's hard to get something in a clipper type variety snow event to come through, because usually there's such dry air masses and they get eaten up as you get downslope flow crossing the mountains. So that was one of the reasons why, seeing some of the discussions from that time frame, why they were favoring the lower amounts and kind of got offset or a little underdone for part of their area. And one of the reasons is this jet here. You can see it 250 millibars across Kentucky and West Virginia, and the right rear quadrant of that jet provided some of that lift later that day that caused a little bit more snowfall in part of the state. And I know these two graphics are a little hard to see the details. On the lower left is 850 millibars the morning of, and it's hard to see the isotherms, but there is some low-level warm air advection going on, subtle, but enough to add to the environment there and supporting snowfall. Temperatures -1, -4 at 850, warming from the southwest. And then at 500 millibars, you can see the short wave there, somewhat disconnected from one a little farther north towards Hudson Bay, not quite in phase, quick moving clipper type thing that's going to head off towards mid-Atlantic and drive the system out of here quickly. So the bulk of the precipitation that fell was late morning through the afternoon for the Raleigh area. And when you look at the antecedent setup and the forecast expectations that they had, these two plots, I think, tell the tape of the antecedent conditions here. 2-meter air temperatures in the top left. And sorry, I don't have the times on there. They got cut off, but January 19th, the morning of, starts there with that drop in temperatures around 15 degrees air temperatures that morning of the event, and then warming up during the day to around 30. And then if you look at the soil temperatures, the 4-inch soil temperatures there at Lake Wheeler Road Field Lab, I don't know exactly where that is with respect to the center of Raleigh, but it's in that area. But the ground temperatures were about 33 degrees, and some of the DOT road temperatures that morning were in the mid to upper 20s. I mean, the asphalt temperatures will warm and cool quicker than the soil temperatures, and for the most part, what they're consisting of. And when the analysis showed after the event the liquid to snow ratios, they were anticipated to be on the high end because of the air mass that was in place, and it turned out that we had 16 to 22 inches to 1 was what was observed. And I think for the most part, we're typically seeing like 8 to 1 ratios or 10 to 1 for our part of the state. And the precipitation was coming in from the northwest, as you can imagine, moving towards the east and southeast, and again, mid-late morning through the afternoon. And that the forecast, again, was a little underdone in part of their area. So when you talk about the human behavior and the societal issues, I kind of joke. I was talking to a reporter yesterday with the Sun News that I wish I would have had a degree in not only just meteorology, but also social science, and trying to better understand what's going on in the mind of people. And one of the things that we see this with rainfall amounts and snow, we do as well. If we're saying only an inch of snow and not putting it into the context with respect to painting the picture of impacts, then people don't see it as a threat. Or even a 1/4 inch of freezing rain, people go, well, it's only a 1/4 inch, not really understanding of what is going on. So I think there's opportunity in our weather stories that if we know we're going to have a low amount, high impact event, it might be better to focus on images of what could happen of the environment and not focus as much on the amounts. That might be able to help with our IDSS as well in briefing our partners. And as far as the second bullet there, not prepared for winter weather in the south compared to other areas, and we're on the southern end of the snow belt. So I mean, the more you practice something, the better you get at it, no matter what we do. And we just don't have the opportunities to really develop a great group of winter weather driving experts in our area. We just see it so infrequently that it's no wonder we get caught off guard with it, or drive too fast and not anticipate like we would. We just don't have that skill set there compared to other parts of the country. And one of the problems in this particular case that really enhanced it was when the snow started falling, I think the businesses and the schools, they started to panic. They let out early, as a result, there were thousands of vehicles on the road, and that compressional effect of the car driving, or the bus or the truck driving over the snow, caused melting, and then it refroze right to the road surface. So the snow quickly turned into sheets of ice as a result of the vehicles going across it. So they're basically digging their own hole in this case. And the other thing too is, people, and we shouldn't expect them to understand antecedent conditions, but we obviously do. And I think that's a great segue into why we do issue warnings and advisories based on impacts. It's not always the amounts that are the key. It is in some sense, but where people get hurt, it doesn't take much with a little coating of ice in this type of case. So while we don't expect people to understand these antecedent conditions, this is our opportunity again to use the weather story and paint that picture of potential impacts based on what we know ahead of time. Just some things I got from Raleigh. Nick gave me these years ago, soil temperature considerations, what they look at. And in general, we're looking at soil impacts melting from a warm ground. Obviously, the heat released from the ground can melt snow or sleet. The heat from the soil can also limit the ice accumulation at ground level, but we could still, even with a warm ground, still have problems on elevated surfaces. And that's what I think we do a good job of focusing on, those elevated roadways and bridges when we have those types of situations, which seems to be a lot of them, of the events that we do have. And factors that need to be considered, again, and I'll look at some of these temperatures of the 4-inch level soil temperatures, and we get a few of them from our co-op observers. But the other consideration is, can you have precipitation rates overcome the soil temperatures? And I remember a case maybe 15, 20 years ago where we weren't expecting much in the way of accumulation because of the soil temperature, but we had a snowburst, and Bladen County in particular, where it overwhelmed the soil temperatures and actually ended up cooling it off quickly, and we did get accumulations from that. So the intensity of the snow can be a big factor along with the soil temperatures themselves. And here's some of the key temperatures that Raleigh notes. If the ground is 42 degrees or colder, then little melting is expected. If it's 47 degrees or warmer, then significant melting is expected. And if the ground is in that sweet spot between 42 to 47, then the temperature of the air will be key. So any frozen precipitation will melt until that air temperature drops 35 or colder. Not a picture from our CWA, obviously, but we've had some significant ice events in our area, and these freezing rain events can be self-limiting, just the way that the heat is released by freezing rain, unless there is an infusion of colder or drier air that would support colder temperatures or more evaporative cooling into the area. And so as far as talking about the precipitation timing issues, it is one of the things that always comes up when we do briefings for them. So if there's a way we can capitalize on a timing graphic for our weather story or for our briefings, I know it would be very useful, but obviously we would have to stay on top of it, because any subtle change, you would have to highlight that as well. So include it in briefings and social media where we can. Is the precipitation going to be coincident with a rush hour, or is it going to be coincident with holiday travel, the behavioral things, the human element things? Are the impacts going to be enhanced as a result of that, versus Sunday at 4 in the morning type of thing, where we know we don't have kids getting ready to go to school and people aren't going to be going to rush hour. It might be church or Sunday activities where it's a bigger issue then. And with the timing, we can only do the best we can. Try and be as specific as we can, especially if we're seeing the whites of the eyes of this event. Farther out in time, I know it's harder to do. We can give them general ideas, say Tuesday morning or something like that. But if it's the day before, try and get as specific as we can with the timing, and update, obviously. Send out a blast email list if the timing is going to change too, because a lot of the decisions the emergency managers are making are based on that timing, whether to open a half day with schools or county buildings, things like that, are closing earlier. And you can look at this two ways. Don't forget about the 2/3 rule or the 1/3 rule. with respect to the effects of evaporative cooling on wet bulb temperature, and this ties into timing as well. When that precip arrives, it can really dictate what occurs, and I'll give you an example here in a second. So the 2/3 rule is how the wet bulb temperature will end up as a result of what the initial temperature and dew point is. So you take the difference between the temperature and the dew point at the onset of the precipitation and find out what 2/3 of that difference is and add it to the dew point. Or however, if you prefer the 1/3 rule, take the difference between the temperature and the dew point, find 1/3 and subtract it from the temperature. And it's pretty good with when that column saturates as a result of evaporative cooling of what your actual air temperature will end up being. And timing of that precip could significantly alter what happens. And I'm just going to give you a real basic example here of the 2/3 rule. And we're going to assume no advection of drier air or wetter air into the area. So we're going to start with the same dew point with no advection. So let's say we anticipate the precipitation arriving tomorrow at 7 a.m. and we anticipate the air temperature at that time frame to be 40 degrees over 10 degrees dew point. You know, with evaporative cooling and applying the 2/3 rule, so that's a 30-degree difference. 2/3 is 20 degrees. Add the 20 to the dew point, and hence we come up with an air temperature of 30 degrees once that column saturates. So here we will have, in the least, freezing rain and P-type issues based on the role of evaporative cooling. But let's say for some reason our timing is a little off and it's delayed by a few hours, and before the cloud shield spreads over our area, we get a little bit of sun from that time frame, and we have the precipitation arriving at 10 a.m., but the temperature's warmed up a little bit during that time frame. So that delay in the precipitation arriving, if we use the 2/3 rule of now an air temp of 45 degrees over a dew point of 10, then the evaporative cooling would lead to an air temperature of 33 degrees, so nice cold rain here. So timing has a meteorological aspect to it and what we actually get, and timing actually has a role into who it may affect given the time of a day that it is with what human activity is going on. And overall, those antecedent road conditions can really play havoc. And we do have contacts with DOT in both states. I really need to see who our primary contacts would be heading into this season. I'm sure people have moved on since last year. So I'll have some information on how to get road temperatures if we need to before an event here in the next couple weeks. So I think that was pretty much what I wanted to share. It doesn't take much to have a catastrophe on our hands. I think our strength is with our briefings and with our social media now, and focusing on painting a picture and advertising those impacts is going to go a long way in helping people understand what can happen even during these very low amount type of events. So that's all I had. I don't know if anybody had any questions.
Steve, I have a comment.
Yes, Doug.
Hey, my dad used to work for the New Jersey DOT, and he was responsible for the Garden State Parkway and surrounding highways. And in this instance, what you just spoke of, they were out there within, I guess, as soon as the forecast was issued for a half inch, they were out there on the roads spreading salt and sand and whatever the mixture that was required back then. Down here, it's just not, they're just not that well equipped, and they've gotten a little bit better over time since I've been here. But like you say, society down here is not prepared for something like this, and it's definitely an impact driven rather than a amount driven type of event. That's it?
Yeah. Oh, go ahead. I'm sorry.
No, that's it.
Yeah, and you know, I misspoke too when I mentioned that ice storm back in 2005. That's when we did the paper. The ice event was 2004, but that 2014 we had an ice event. I thought I had a picture of it up, but I don't. I'll share it with everyone with the significant accretion that was going on. And before that, the 2014 2014 ice event, we had that sleet event, which was on the beginning of Vicky's presentation, and those antecedent road conditions, that was an Arctic air mass as well. And we never warmed up for 3 days. So the antecedent conditions combined with the duration of that cold air mass that followed that system in addition, we had, I believe, 3 days worth of just sleet that was melted and compacted, and the plows that we have and the limited capabilities that we have in the area. I remember seeing videos of plows just riding right over the compressed sleet, not even doing anything. And that was a real extreme case, plus the amount of slips and falls. So when we know we're going to have a cold ground, we really need to hit hard the driving hazards on all surfaces, and we also need the slips and falls. It's about 20% of winter-related injuries are from people with slips and falls. And that sleet storm back in 2014, I remember talking with emergency management and New Hanover Regional Medical Center. They had, I believe, 75 slip fall cases, people coming into the hospital. That's how bad it was. So you can imagine how many people fell that didn't go to the hospital, maybe a little less minor type of injuries. So, I mean, I know we like to focus on the timing, which is great, and the amounts, which is great, and where, but we have to be steadfast with those antecedent conditions as well and what that means to us.
Steve, can you hear me?
Yes.
Given this presentation and the fact that it has this kind of impact, maybe we should consider augmenting our advisory and just go with an advisory for any amount of snow if we don't expect it to melt on the roads very much.
Yeah,
something to think about, because just the criteria for just the amount, we can see how it can fail.
Yeah, and I think that's what bit Raleigh that day. And again, it was in an environment where it was purely based on numbers and not impacts. And if we see that clearly, we should definitely make that a consideration, or at least a footnote in the criteria. A strong
I think
kind of like when the ground's wet, we don't quite have wind advisory criteria, but we go with it anyway because we know some trees are going to fall.
Right.
That's kind of a parallel to that, I guess.
Yeah, exactly.
That's all.
Yeah. Yeah, I think Mike, I believe Mike, actually in the directive we totally have the leeway to issue a winter weather advisory if it's purely just impact based. So there's a lot of I know for us our criteria is low, but having worked offices further north, if you don't meet the criteria for advisory, but if you have a smaller snow like around rush hour, you have the leeway in that situation to issue an advisory, like kind of like what you're saying. So.
Okay, that's good to know, because it's become so infrequent here that, boy, when it happens, it's going to be probably, well, potentially a mess. All right, thanks, Matt and Steve.
You're welcome.